Alright, my name is Robbie and today I'm going to show you how to solve this circuit using the node voltage method. So before we begin, I just want to make sure that everyone already understands what voltage, current, and resistance are because we're going to use that a lot in this video. So the first thing we need to identify is our reference node. There are 2 points in the circuit, here and here, which act as junctions between our circuit components. And so I'm going to go ahead and pick this top one here, and that's what we'll work with. And that node will have a voltage of N. And the bottom has a voltage of 0, and we'll let that act as our ground point. Okay, so with this node voltage, we understand that all of the currents coming out of this circuit, here, here, and here, all of these currents add up to 0. So this is I1, this is I2, and this is I3. So that means that our first equation is I1 plus I2 plus I3 is equal to 0. Unfortunately, we don't know what any of these are, and so what we need to do is get each of these currents in terms of their resistances and this node voltage. Right? So that way we only have one term that we're missing and we can solve for that, and then hopefully plug that back in and solve for each of the 3 currents individually. So our second equation that's really important is one that you guys might see a lot, which is V equals IR, which is Ohm's law, or more importantly, I equals voltage over resistance, which is what we can plug right back into here. So that means that we can go ahead and get an equation for each of the 3 currents individually. So I1 is equal to this node voltage minus this 5 volts, right, over 2,000 ohms. So that's N minus 5 all over 2,000. And the reason we say it's minus is because this 5 volts is pushing positive current this way, but we need our current to move this direction. We're going to assume it moves in this direction anyway. And so then we get an equation for I2, and that is just N minus 0 over I2. So just N over, R2, which is 1,000 ohms. And finally, we have I3, which is almost the same as I1, except just a different resistor value. So we have N minus 5 volts over 3,000 ohms. So N minus 5 over 3,000. All right, so now that we have I1, I2, and I3, we can put it back into this equation and set it equal to 0 again. So we have our third equation, which is N minus 5 over 2,000 plus N over 1,000 plus N minus 5 over 3,000. And all that again equals 0. So at this point, we're going to go ahead and skip the algebra for solving for N, and I'm just going to go ahead and tell you the answer, which is N equals 2.273 volts. Right? And we get that just by getting N by itself and moving all of the fractions over to the right side. Alright, so now that we have the node voltage N, we can simply plug it right back into our I1, I2, and I3 equations, and we'll know what these currents are. So, again, I'm going to go ahead and skip a little bit of the algebra for you. This might be a little bit simpler than this equation, though, and I'm going to go ahead and tell you what they are. So, I1 is equal to, let me check here, negative 1.365 milliamps. Alright, and you might say, well, why is it negative? Well, that's the thing. This current, we arbitrarily assumed that it was going to move in this direction, and it gave us a negative value. So what that really means is we can simply change the direction of this current, and we understand that it's now positive current traveling in clockwise direction, which makes sense with our positive voltage. Alright, and I2 comes out to equal a positive 2.273 milliamps. So that one had the correct direction of current. And then finally, I3, which gave us a negative 0.909 milliamps. Once again, this negative current in this direction means that a positive current is actually flowing in the counterclockwise direction. Just had to make sure right there. So we can write the arrow going this way, mark off the negative, and now we have a positive current. All right, and folks, that's pretty much it. We may have moved through that a little bit fast, so if you need to, feel free to just pause the video, go back, stare at it a little bit, and let it really sink into you. This is a method that's really common, it's used very commonly in simple circuit theory. Excuse me. All right, well, thanks for joining me, and I appreciate it.